Since its invention in the early 1900s, the mechanical seal has been evolving steadily. Early stationary and rotary component seals were followed by self-aligning stationary designs, first as component seals, then as cartridge seals. Although each of these designs offered state-of-the-art performance in their time, new materials and design techniques have made more reliable and economical sealing possible. Chesterton combines the best technical features of stationary, rotary, and self-aligning seals in a third-generation design far superior to all current single seals. The 155 Cartridge Single Seal. In the 155, the rotary and stationary seal faces are supported on the shoulder of the shaft sleeve. The rotary components are the rotary seal face, the sleeve, and the lock ring. The stationary components are the stationary seal face, the drive ring and springs, and the gland hub and tabs. The process fluid is contained at the outside diameters of the seal faces. The 155 is the first cartridge-mounted stationary spring seal to achieve rotary face squareness to the shaft while compensating for stuffing box misalignment. In stationary spring seals, the stationary is independent of the gland and therefore is not affected by stuffing box misalignment. Face squareness is totally dependent on the perpendicularity of the rotary face to the shaft. It is impossible for an ordinary cartridge stationary seal to maintain rotary face squareness. Tightening the first set screw of a conventional lock ring permanently pulls the sleeve off-center, so the rotary face is not square to the shaft. As the shaft turns, the stationary seal face compensates for the lack of squareness by moving back and forth. This movement causes fretting of the metallic surfaces, clogging, and O-ring hang-up. Unlike conventional stationary and rotary designs, the 155 includes a patented self-centering lock ring that establishes accurate rotary face squareness to the shaft. The 155 lock ring has a built-in mechanical stop that prevents the lock ring from mis-centering the sleeve. It features 3 centering set screws in addition to the standard drive screws. These 3 centering screws work together with a built-in stop to precisely center the seal around the shaft. When the first centering set screw is tightened, the bottom lip of the lock ring holds the body of the lock ring away from the sleeve. The sleeve contacts the shaft at the point where the set screw is tightened. Tightening a second centering set screw deforms the sleeve enough to force it into a second contact with the shaft. After the third centering set screw is tightened, the sleeve is clamped in a symmetric 3-point contact to the shaft. This symmetric contact holds the sleeve concentric to the shaft. The shoulder of the sleeve is now perpendicular to the shaft. Consequently, the faces supported by the shoulder are also perpendicular to the shaft. And because the drive and centering set screws can be tightened in any order, installation is both accurate and simple. Exclusive dynamic stress relief maintains face flatness during pressure and temperature changes. Ordinary seal faces can distort when subjected to typical process temperatures and pressures, causing excessive seal face wear and emissions. The 155 seal faces were developed using computer modeling and extensive laboratory testing. These techniques help to create a face profile that minimizes the destructive effects of thermal and hydraulic forces. Deflection caused by these forces is directed away from the face surfaces to a non-critical location on the seal rings. The one-piece low-profile faces stay flat despite pressure and temperature changes, and during transient surges at startup and shutoff. Profile analysis proves that the faces of the 155 wear extremely evenly compared to ordinary seal faces for reduced fugitive emissions and reliable long life. The adjustable gland of the 155 allows the seal to fit most equipment bolt circles without modification. The gland has movable spring-loaded slot tabs that can be repositioned easily. Bolt circles with 2, 3, or 4 studs can be accommodated. Custom gland requirements are virtually eliminated. These movable tabs also permit the flush port to be rotated to any desired location. There is no need to reposition the flush piping. The 155 is also available with a multi-port flush and quench gland that exceeds API standards. The patented centering strap is an advanced replacement for centering clips. It automatically and positively sets radial and axial seal positions for quick and accurate installation. No centering clips, screws, or hex keys are required. If impeller adjustments are necessary, the strap can be reinserted so that the seal can be reset after the impeller has been moved. The 155 features a non-destructive chassis design with modular faces for easy repair and upgrade in the field. The metal chassis of the seal, the sleeve, lock ring, gland hub, and tabs do not wear under normal circumstances. Only the faces and hardware need to be replaced to repair the seal. There are 4 standard face materials available. The faces can be changed to suit virtually any operating condition. The 155 faces are interchangeable with the 255. In an emergency, a 255 spare parts kit can be used to get the 155 running. The 155 can be quickly repaired or upgraded by the user in the field. Simply remove the old faces and hardware and install the new spare parts kit. The Chesterton 155 seal incorporates many advanced technical features that contribute to its superior performance. The self-centering lock ring establishes accurate face squareness to the shaft. Dynamic stress relief maintains face flatness during pressure and temperature changes. The adjustable gland can fit a wide variety of bolt circles. The centering strap allows fast and accurate installation. The non-destructive chassis design reduces the cost and complexity of repair. The modular faces simplify repair and expand the application flexibility of the seal. These features combine to create a seal with superior emissions control that can help industries safely achieve environmental compliance. A seal with longer mean time between planned maintenance for reduced maintenance costs and production downtime. A seal with the versatility to work reliably under many operating conditions at higher pressures and temperatures than typical single seals, so inventory costs are decreased. A seal that is easy for the user to rebuild and install reliably in the field, reducing repair time and costs. The 155 Cartridge Single Seal, the latest advance in seal development. With superior technical and commercial advantages, it sets a new standard of performance for single mechanical seals.